Okay, hello everyone. I'm Dr. Danielle Wain, the Lake Science Director at the Seven Lakes Alliance. Today I'm going to give an overview of where we are this summer in terms of water quality in the lakes, including some of more pressing questions we've been getting about things like how the alum treatment's holding up in East Pond, and what's going on in North Pond, which we've been speaking a lot with the folks on North Pond, but I know there's a lot of curiosity throughout the watershed about what's going on there. Before we get started though, I want to thank everybody who helps make our water quality monitoring possible. And first off, this summer we don't have any Colby interns, but we've had Colby interns since 2015, and they're an integral part of collecting all this data, which some of it I'm going to show you. So volunteers from the various lake associations who've helped us and takes us, especially this summer, I've been so grateful to everybody who's taken me out on their boat to get samples. Also my fellow staff at Seven Lakes Alliance, who have also come out and done water quality with me. Especially this summer, I want to give special thanks to Dr. Whitney King and his wife, Jan King. I didn't have a photo of her, so that's a stick figure drawing, of course, but they've been essential this summer in helping us collect all our water quality data because since they're married, can go on a boat together. We've really relied on the data they've collected, and they'll show a lot of that here. I've collected some as well with volunteers from lake associations, but yeah, Whitney and Jen have been key this summer in helping us maintain these long-term data sets, which really let us look at what's going on in the lakes. So first, an overview. There's a pretty big group here today, and some names I know and some I don't. So I just want to give a little bit of an overview first of what we do. But I guess first, we have a poll question to see where people are from. Raina, do you want to launch that? Okay, so we have a lot of North Pond people here. That's great. So you'll see some. I'll repeat some of the things that Whitney spoke about at the North Pond Association, but also obviously be talking about all the lakes. Great to see a wide variety of people from around the lakes. Okay, well, just to give an overview of what we do, our baseline water quality monitoring involves several types of measurements. And the first one is measuring temperature and oxygen. So that gets us its profile of what temperature goes at the top down to the bottom, and also dissolved oxygen from the top into the bottom of the lake. And this is important because oxygen is one of these key water quality parameters. So we want high oxygen in our lakes because it usually indicates we have good water quality. So we're hoping we have high oxygen. Fish like high oxygen. Once we get below 5 parts per million, that's when fish, particularly cold water fish like trout and salmon, really get unhappy, and it can affect the fisheries. And then even lower than that, below 2 parts per million, that's when we start to see the release of phosphorus from the sediments. And we're going to talk a lot about phosphorus today because it's a really important nutrient which fuels algal growth within all of our lakes. So the second thing we do is we use this water sampler here, and here we have Linda Rice and Woody Woodson on North Pond collecting water samples. And we use this water sampler to collect samples at different depths of the water column so we can measure how much phosphorus is in the water. And again, that's because phosphorus is fuel for algae. I want to thank Pine Tree Camps for this photo of this drone photo, which shows the bloom in North Pond, and this is, it's phosphorus, which is what's driving these blooms. And so we need to measure, we need to know how much there is so we can start to talk about how we manage it. So where does phosphorus come from? Phosphorus can come from a lot of places, and every lake is different for where most of the phosphorus comes from, but it can come from the atmosphere, it can come from groundwater, it can come from wildlife, but a lot of the biggest sources can be watershed runoff. So what's coming through the land that runs into the lake, and it runs off and it brings phosphorus with it. This internal recycling from the sediments, that's what I was saying, when you have no oxygen, when you have low oxygen, you get phosphorus coming from the sediments, and then it's available to algae. You also have inflows from the other lakes, so upstream sources, but also septic systems. So this is kind of the broad area of where phosphorus can come from, and we're doing a lot of measuring what's going on in the lake so we can help to start understand where phosphorus comes from in each of our lakes. And then finally, we do Secchi disc measurements to measure water transparency. And if you haven't seen a Secchi disc before, it's basically just a black and white disc that we lower down until we can't see it anymore. And then we use that as a measure of water transparency. And this is a measurement that's been done for, over 100 years around the world, but within the Belgrades, we have records going back to the 70s for Secchi measurements. So it's really important for us to be able to see how the water quality has changed over time. So that's an overview of all the measurements we're going to do. I'm going to show data from these types of measurements in this talk. So I just want to make sure people understand where it comes from. And all that, again, all that data comes from basically a team of people going out to collect data on all the lakes. And it's a big endeavor and a lot of work. And so we need very grateful for all the people who help with that. So the first thing, when we start talking about this summer, is talking about, is it really, this summer, this is only my second full summer in Maine, but I grew up outside of Boston, and I sure as heck feel like this has been a hot summer. And yes, and the data goes to show that this has been a very hot summer. This is the NOAA data from June, which is the most recent data that we have, but you can see that this summer has been hotter by a few degrees on average than any summer in the past, any June in the past decade. And so why is this important? Well, the first thing is that when it gets hot early, you get stratification early in the summer. And so that's when you start to have this temperature gradient. And that temperature gradient then influences how much oxygen you have. So the earlier you have stratification in your lake, the earlier you get low oxygen in your lake. And then finally, that means the earlier you're going to get phosphorus released from the sediments in your lake. So basically, this makes 2020 a challenging year for water quality in our lakes because the weather is just working against us. We basically had August weather in June, and that means that our lakes responded early to the heat, and they've been set up the stratification and low oxygen earlier than they usually are. So this has been a challenge for our lakes, but some of our lakes are more resilient to this kind of weather patterns than others. And so we'll talk about that briefly. Some of you may have seen these slides before. We have two types of lakes in the Belgrade Lakes. So Great Pond is an example of a dimicdic lake, and that means it mixes twice through the year. What I mean by that is that at the end of so this graph here, see if you can see my mouse, this is depth, this is time, this is the day of the year, so May, June, July, August, and this is temperature. So the red temperatures are really hot, the blue temperatures are cold, and shows us how temperature changes in the lake with depth and time. So at the beginning of the year, it's all kind of cool because ice has just come off, and we call it the spring turnover. It's all mixed up right now. So then the sun comes out and it starts, and it gets warmer. And then you get what we call the stratification onset. So it starts stratifying. And then Great Pond will stay stratified basically until the autumn when the thermocline just gets deeper and deeper, and eventually the wind just mixes it up. So it's called dimicdic because it mixes in the spring and mixes in the fall. So the dimicdic lakes are relatively more stable than the other types of lakes we have in the Belgrades, which are the polymictic lakes. So poly means many, mictic meaning mixing. So we have here, this is data from 2019 from North Pond, and again, it's the same thing. We have time and depth and temperature. And so what happens with polymictic lakes is you get the spring turnover like we have before, but then you get, the sun comes out, it gets warmer, you get these temporary stratification events. And then the wind comes and it mixes up, stratifies again, the wind comes and mixes it up, stratifies again. So you see it's mixing many times during the course of the summer until the fall turnover. So that's what we call polymictic because it mixes many times. Now, what that means in terms of stability is that our polymictic lakes are much more susceptible to the weather drivers because they're more likely to mix and stratify based on what's going on in the environment, versus the dimicdic lakes, which are our deep lakes, Salmon, Great, Long, and Messalonskee. All those lakes are fairly stable because they're just so deep and it takes a lot to mix them up. So while the surface may be mixing, they never completely mix, and that's why they're able to resist some of these weather patterns better than the polymictic lakes. So first, I'm going to talk about East Pond, which is the first of our polymictic lakes. And so this graph here is the graph of the Secchi depth versus the day of the year for all the last 5 years. And the way we look at this is a low Secchi depth means you don't see very far in the water, so the water quality isn't very good, it's bad. And when it's big, that means you could see far into the water. The red line is what the DEP calls the barrier between eutrophic and mesotrophic lakes. So you don't want your lake to be eutrophic, that's bad. So if we look at this data here, first I want to point out that all this data up here is pre-alum treatment. So again, this is in the year day, so the day of the year. I made a dashed line for today's date. So you can see relative to this date in the past where East Pond was. And so this is about the time of year that East Pond would start. And the Secchi depth would go up quite a lot because of the algae. So we have this low Secchi depth that used to occur, but then we look at 2018 and 2019 and we see it stays good for the whole summer after the alum treatment. Right now, you see the yellow star, that's where we are currently in terms of the Secchi depth. So that's the most recent Secchi depth measurement we have, and it's pretty on par for where we've been in the past couple years. You can see that in 2019, it was a little better right before, but then it popped up to about this level about this time of year. I'll note that in 2015, it was also at this level, and then it still bloomed. But again, if we look at that weather data, you see 2015 was a really cool year, and so relatively cool year. So, so the fact the bloom started later is not surprising, but this year is quite warm, so that's why, for instance, the bloom on North Pond started so early. So that's looking at the Secchi depth data. Here we're looking at the phosphorus. So again, we want low phosphorus in our lakes because phosphorus is that fuel for algae. And it's the same thing. It's the day of the year. I made a dashed line on the current date, and then the different colors represent the different years of data. The red line is also this barrier between where we don't want our phosphorus to be above 20 parts per billion. So the top panel is surface phosphorus and the bottom panel is bottom phosphorus. So, and when I've circled here again is you can see most of the high phosphorus measurements at this time of year were before the alum treatment happened. And then after that, we've kept the phosphorus down. So on the surface, you can see the phosphorus is quite good. Now, you may have noticed that actually the star indicating where we are this year, the phosphorus in East Pond in our last measurement was higher than we would like to see, to be honest. And Whitney and Jan are actually going out tomorrow to do another set of profiles on East Pond. And part of that is because we moved the buoy that we use to mark our location where we measure in East Pond before making that measurement. And so it could be that we just disturbed the sediment and it kicked up some phosphorus. That's what we're hoping is the situation here. But we're keeping an eye on it and we're monitoring it. I think the people who live on Nome from East Pond has complained about the water clarity at the moment. So I'm assuming that even if the phosphorus is a bit high at the moment, that the water clarity is still good. We know that from the Secchi depth measurements, but we're keeping an eye on it because we want to make sure to monitor it to see how the treatment's doing and how long it's going to last. And so that is a measurement that worries us a little bit, but that we're keeping an eye on. So now we're going to talk about North Pond. So this is again that same graph. That red line is we don't want to be above that red line. So the green and the red dots are all before. So in 2018 was really the first year that we started having bloom. So those are the blue and purple dots are 2018 and 2019, and the red and green ones are the data from before that. And so you can see there's a lot more data above this line in 2018 and 2019, including the most recent data that we have from the lake. But, you know, one thing that's really important to notice about North Pond is that even before 2018, there were a lot of Secchi measurements that were pretty close to that boundary. So North Pond has always been a bit of a lake on the edge. And unfortunately, it got tipped off the ledge in 2018 and hasn't recovered since. And so this is important to keep in mind because it's not like the lake went from perfect to blooming overnight, right? There's already lower water clarity than one might hope in the lake. It wasn't bad, like in the sense of way people liked enjoying the water, but it certainly wasn't as high as we would have liked. And this is seen again when we look at the phosphorus. So again, we see a lot more numbers in the blue and purple years, so 2018 and 2019 above this red line, particularly at the surface. But Near the bottom, we do see phosphorus was up near that red line. So we already had some pretty high phosphorus in the lake. So the lake was basically primed to bloom at some point. And the weather in 2018 seems to have been just enough to tip it into that state. So it's a combination of things that lead to these conditions, but a lot of it has to do with watershed runoff and the phosphorus coming in from the watershed. North Pond has a high flushing rate, so it gets a lot of it. The water changes out every year, basically, but all that's coming in from the watershed into the lake. This year, the phosphorus is, the latest phosphorus measurements are around 30 parts per billion. And so that's pretty high. And again, we're seeing what we expect when you have phosphorus that high. So what does that mean in general? So basically, to go over what's happening, this is what used to happen in East Pond and what's currently happening in North Pond. And there's some big jargony words, but the eutrophic polymictic cycle. But basically, what happens when you have a lake that's prone to algae, that's polymictic, so mixes a lot. So the lakes generally will mix in the spring and into the early summer. And then if you do have some stratification that happens, when you get calm, warm weather like we had in June, then you get the stratification set up, you start losing oxygen, and then the phosphorus comes out of the sediments, and then you get this mixing event, mixes it up, brings the phosphorus up to the surface where the algae can use it. Then you reduce the water clarity, which makes stratification even more likely to happen. And this whole cycle keeps repeating, pumping the phosphorus into the lake. Now, it used to be that North Pond would always just mix up continuously, so it never stratified. And that's why we didn't get this phosphorus coming out of the sediments. But in 2018, it started stratifying and the phosphorus started coming out and it started this cycle. And this is a very difficult cycle to break. So, but for all lakes, the water clarity influences how much stratification you get. The clearer your water is, the farther the sunlight penetrates, and that means you can stay completely mixed if you're a shallow lake. So the water clarity is influencing the stratification and the water quality, but then those things then go and influence the water clarity, and then it goes in a cycle, and this is called a feedback loop. We call it a positive feedback loop because it accelerates the process, but obviously it's a negative thing that we don't want to see happening. And this is how you end up with conditions like this, with the current algal bloom that's happening in North Pond. So I'm going to talk a little bit more about the current bloom. So the water clarity is less than 3 feet right now, which the Maine Department of Environmental Protection considers to have the potential to be a harmful algal bloom, which is, so that means we're very much trying to monitor this and see what is going on in the lake. So, but I want to talk a little bit about algae because I think sometimes we give all algae a bad rap, but algae is an essential part of our lake ecosystems. It's the base of the food chain. That's how the algae is eaten by the zooplankton, which are eaten by the small fish, which are eaten by the big fish. If you don't have algae, you don't have a lake ecosystem. So this is a slide from the Maine DEP, which talks about how algae changes over the summer. An oligotrophic lake is a very healthy lake. So eutrophic lake is a lake like North Pond is now, so it has a lot of algae in it. At the beginning of the year when it's cold, almost every lake has something called diatoms. And diatoms are a type of algae that use silica, and they make kind of cool snowflake-looking patterns, not snowflakes, but different shapes and structures because they use the silica as part of their structure. Those die off, and then in a healthy lake, give way to green algae, which again are great food for all the things we want living in our lake. Then eventually, even in the best of lakes, you get a blue-green algae bloom. You get blue-green algae, or cyanobacteria. They're the same name for the same thing. Even in a healthy lake, you're going to have blue-green algae. That's just part of the way lakes work. And part of that is blue-green algae or cyanobacteria have been around for millions of years, and they've developed these really good adaptive mechanisms to thrive in any environment. That's why they're so hardy and so basically impossible to get rid of completely. But then in a healthy lake, They don't overwhelm the system. They eventually die off. And then when it gets cold again, you get more diatoms. So on the right-hand side, we have a eutrophic lake where you start with the diatoms, which is what we saw. And we saw both in East Pond and North Pond, the water clarity was only 2 to 3 meters. And that's usually because you have a bunch of diatoms blooming. Then the green algae comes and the water clarity gets better. But then as we see in North Pond, the blue-greens went up. They just exploded. And that's where we are now. So we need algae in our lakes, but we want the right kind of algae in our lakes. The other issue with cyanobacteria is that they can produce toxins. And this is, of course, what a lot of people are concerned about. So the first thing I should, the type of algae we have in North Ponds, this is from an instrument called a flow cam, which basically we take a water sample, we run it through, and it zooms up the flow so we can take pictures of the algae in it. So these little balls and spirals, those are a type of algae called Anabaena, and that is what is blooming in North Pond. And that type of algae can produce toxins. So big question is this bloom toxic? So just today, we collected samples up on North Shore Drive, down at Pine Tree Camp, at the 225 bridge and at the mouth of GMS. And we ran a test to determine if there is a toxin called microcystin within the lake. So the reason we're testing for microcystin is because there's a lot of very good there's a test kit that we can use, which is fairly straightforward. It basically is like an advanced pregnancy test that lets us tell if microcystin is in the system. But also this is from discussions with the Maine DEP, who a couple of years ago did a study where they took water samples from some of their lakes that were blooming and sent them away to another lab to do a full toxin analysis of all the different types of possible toxins. And the primary one that showed up is microcystin. Microcystin is a liver toxin, and it's a kind of a slow acting toxin. So that means microcystin is not the type of toxin that kills your dog. We actually haven't had any detected levels of those type of toxins in Maine. So it's more of you don't want to consume a lot of it because over time it's going to harm your liver or any animal's liver. So whether that's you or your pet. So it doesn't have an acute impact, but it has long-term impacts to people's health. So this is why it's important for us to know whether or not bloom is toxic, and microcystin is the biggest candidate for the toxin that might be present. So good news is we tested at 4 sites today, and all the tests were negative. So despite all the algae growing in North Pond, despite all the algae traveling down Great Meadow Stream, which I know there's several people who have questions about that, none of it has detectable levels of toxins. And so we're going to continue to be monitoring this for the rest of the summer. The plan is to try and to do toxicity testing every week, because this can change very quickly, because it's still not really known when algae are going to produce toxins. This is one of these big challenges that in the limnology field and the study of lakes is understanding when and why algae, the cyanobacteria, produce toxins. So instead we just have to monitor and keep our eye on it. So on a related note, one of the times they do tend to release toxins is when they're dying. So this picture was sent to us. This is, if you've been on North Pond, you might have seen blobs like these. This is dead and decaying algae, so you definitely want to stay away from blobs like this. You also want to stay away from swimming in scums. I mean, no one wants to swim in a scum anyway, but just because the test came out negative, avoid scum areas, because that's just common sense, and that's where you're most likely to see elevated levels if there is any. What else did I want to say about? Just also keep in mind that just because we didn't detect microcystin doesn't mean that the algae might not irritate some people. Certainly on East Pond, there were, I've heard many people talk about how they couldn't shower with the water in East Pond because it made them itchy, these kind of things, and they didn't have microcystin in their water either. So, so do be cautious. You should limit your exposure to the water, even though, limit your exposure to the water, avoid ingesting it in any way. These are the things you need to do to stay safe with the water that's currently on North Pond. So So we've talked about the lake stability. And so we talked about East Pond and North Pond, which both have had a fairly, well, East Pond had a history of blooms and now North Pond is blooming. So that may lead some people to think, well, what about McGrath? So first I want to talk about, you can see how different McGrath is. And this is why McGrath has a little more resiliency and stability than the other two lakes, because first, this is our Secchi depth here. And you can see all the Secchi depth measurements we've taken in the last 5 years in McGrath have all been below the bad line. The most recent one is a little bit higher than it typically is at this time of year, but not distressingly so. Then we look at the phosphorus, and we see almost all the phosphorus measurements we've taken on McGrath in the last 5 years have been below the red line as well. So what this just means is that McGrath has a little more, that isn't teetering on the edge like North Pond was. But it does mean it's still a lake that will be very sensitive to actions in the watershed, and that's certainly important for people who live on the lake to be cautious of that and to realize that their lake can be very sensitive if you have weather like we currently have. But the other good news from McGrath is the lake in the Belgrades, which has had the most improvement in water clarity over the last 50 years. So you can see the Secchi depth has gotten better and better since the 70s, both the average Secchi depth and the worst Secchi depth measured every year. So right now McGrath is looking pretty good, and even though it's a polymictic lake, but it's certainly a lake that, you know, the people who live on it need to be aware that, you know, you have a lake that could react to the watershed if there was a lot of runoff that reduced clarity. So now I'm going to talk about the dimicdic lakes. That's the other four, the deep lakes, because they have different types of water quality indices that we're interested in looking at. I'm still going to show Secchi and phosphorus data, but I also talk a bit about the stratification. So first, here's what our temperature and oxygen look like. So I'm going to explain how we read these graphs. So I have the 5 lakes on the bottom. LP1 is the upper basin of Long Pond. LP2 is the lower basin. The blue dot, the colored dots are what the current measurements are in the lake. The black dots are the average from around this time of year over the last 5 years. That allows us to compare how we are this year to where we are at this time in the past. So the first thing to notice is that, with the exception of Salmon Lake, the Secchi depth in all the deep lakes is shallower than in the past. And again, that's consistent across basically all the lakes except for Salmon. The Great Pond and the lower basin of Long Pond have the biggest discrepancy. Although interestingly, this is the data on Great Pond, we have 2 sampling locations. One on the southeastern side of Hoyts and one on the northwestern side of Hoyts. This is from the southeastern side. The northwestern side actually had better water quality, but I just picked one site to present today. So, but we see that Great Pond and Long Pond are off by a couple feet in terms of Secchi than they are typically at this time of year. The other metric we're looking at is how strong is the stratification. So that's what that delta T is. What's the change in temperature from the top to the bottom? So from up here to down here. Salmon, again, is a pretty stable lake. Like, it hasn't actually changed much compared to the last 5 years. But the other lakes, so Great Pond, Long Pond, and Messalonskee, are generally all more strongly stratified than they typically are. And why is that important? It's because the more strongly stratified you are, the harder it is for oxygen to get down to the bottom. And this isn't surprising because, again, it got so warm so early that you expect to see stronger stratification. So then ZT is the thermocline depth. So that's where this region right here, the big gradient in the temperature profile. So we want to know what depth is that, because that's kind of the depth where is our barrier for oxygen transport. And actually, it's only in the lower basin of Long Pond is it shallower than what we see typically at this year. So that's good, because you want a deeper thermocline means it's more stable. The next one is how much the lowest amount of dissolved oxygen in the lake. And so across all the lakes, you can see that we're observing lower dissolved oxygen at this time of year than we have in past years. The exception is Salmon, which always has 0 oxygen at this time of year. But the rest of the lakes have lower oxygen at the bottom of the lake than they typically do at this time of year. Again, this relates to the warm June, which set up the strong stratification early. The next one is what we call the hypoxic depth. So this is where the oxygen drops below 5 parts per million. This is where fish are not happy. And that has actually stayed relatively stable. In Great Pond, it's a little shallower than it is in the past, but in the other lakes, it's pretty stable. The other important depth is the anoxic depth. So when it gets below 2 parts per million and when phosphorus starts coming out of the sediments. So if you can imagine, the higher this number, the more area of lake has no oxygen. So we can see basically Great Pond's the only lake that has a higher anoxic depth than it has in the past. But again, what's really interesting is in the other basin, at the other site, it has oxygen all the way down. So it's very different on the two sides of Great Pond this summer, which I thought was really interesting. I'm not sure why that is. So the last two things I'm going to show are phosphorus. So in all the lakes, the phosphorus at the surface this year is higher than it has been in the past. So across all 5 of them. I don't really have a good explanation for that because surface phosphorus tends to come from runoff because all the phosphorus near the bottom is trapped at the bottom till the autumn. But so it is all higher. So that probably is why the Secchi depths are not as good this year as they are in the past. We look at phosphorus at the bottom, they're basically pretty close to what they typically are. You can see salmon is has the highest phosphorus out of all the lakes. And that's because it goes anoxic so early. And it is slightly higher, it's up to 200 parts per billion at the bottom right now compared to where it typically is, but it's usually quite high. So these are just some of the metrics we can look at to see how our lakes are doing comparatively. I think overall, what we're definitely seeing that it's been a warm summer and this has implications for the water quality. So it's a challenge for the lakes to naturally have their best water quality in a year like this. Cool weather helps the lakes, but obviously we can't control the weather. We have two types of lakes in the Belgrades, the Dimicdic ones, the deep ones, and we kind of looked at how those are impacted by this warm summer, and then the Polymictic ones. And then in particular, this warm summer has made North Pond even worse than it was looking because last summer wasn't as hot as this summer. The East Pond alum treatment appears to be holding up, but we need to check the most recent P numbers, and we're hoping it was just for moving the buoy, but we're keeping an eye on it. So North Pond has tipped into a cycle like we used to observe on East Pond. The watershed sources of phosphorus in North Pond are the first things that need to be addressed to help try and reduce this problem. So in general, the water quality this year is not as good as the past 5 years in the deep lakes, but they're all very stable, which means, so when we talk about North Pond mixing up after it stratifies and the phosphorus going to the water column, that's almost impossible to happen on the big lakes. It would require a really big storm to actually mix up that phosphorus. So that's all that phosphorus at the bottom of salmon is pretty sequestered down there until the end of the year at the fall turnover. So that's what I mean when those lakes are a little more stable and resilient to this kind of weather, because you can't mix them up very easily. And that means that they can resist some of these climatic factors that the shallow lakes can't resist. So anyway, I have one question in the Q&A, but I haven't been able to see the chat, so I apologize. So for starting with that, I'll start answering questions. I am going to, let's see. I'll open up the chat and I'll try and, so the first question, and I did touch upon this, that, oh, sorry, yeah, so I couldn't see the chat. I apologize, I couldn't see the chat during this. I can see it now, people asking me about the screen, I apologize. So the first question, is the algae likely to travel downstream to Great Pond from North Pond? And the answer is yes, and it is traveling downstream. We've seen it in Great Meadows Stream. Great Pond is quite big, so it'll be diluted when it gets down there, but we're still monitoring that situation. And that partially, obviously we care about the water quality of Great Pond, but we also have milfoil crew working in the outlet stream at Great Meadows Stream, and so we want to make sure they're safe. And so, so it's important that we keep tabs on what the toxicity levels are, and if it's a threat to anyone, basically to our workers or to residents on North Pond or East Pond, or North Pond or Great Pond. the next question on the Q&A side, then I'll go to the chat window, is what more may be done to stabilize East Pond? So East Pond started the year with higher phosphorus than we would have liked as well. And what that says to us is that we still have work to do in the watershed. So we still need to work on reducing runoff so that in the springtime you just have less phosphorus going in. And that's really the most proactive thing that can be done across all our watersheds. So Lake Smart, using YCC, all these things are important things we do to help reduce the runoff, which helps reduce the phosphorus, which will improve the water quality. Okay, so now I'm going to the chat window. So we have, yeah, so Channel 6 declared that this July was the hottest month on record ever in Maine. So yeah, so that goes along with, I just used the validated NOAA weather to show before, but I know that the pattern was similar. Yeah. So do we know what percentage of phosphorus loading in North Pond is attributable to external loading that can be mediated? This is the big question right now. And this is what we're trying to get a handle on, working with North Pond Association. And there's things we are doing right now to try and address this. And one of the big questions is how much is coming in from all the tributaries into North Pond? So like East Pond doesn't really have tributaries. So it was much easier to estimate how much was in the sediments and how much was from the watershed. But in North Pond, we have several tributaries. We have culverts coming from the road. So Jody and I went out on Monday and put in some auto samplers in some of the, into some of the tributaries. The idea is to try and collect samples when we have a lot of rain. So I have to go back out and see if they survived. I know one of them didn't. We may have to instead use volunteers to help collect samples after it rains. That'll tell us how much phosphorus is coming in. Also working with a professor at Colby this autumn who's going to have her students do a project to try and estimate the flow rates going into North Pond, and then we'll match that up with phosphorus measurements to try and get what's the mass of phosphorus coming in. So this is really important stuff for us to figure out how much is coming from the watershed. There's definitely stuff coming from the sediments, but there's definitely stuff coming from the watershed. And trying to nail down that balance is really tricky. And that's the same kind of calculus and math that had to be done for East Pond that we're doing for Great Pond now as part of the watershed-based management plan. It's not straightforward, and we need some more measurements. The oxygen sensor that North Pond Association bought last year has been sitting in the bottom of the lake, and that tells us how often there's low oxygen. And so when there's low oxygen, again, we get the phosphorus coming out of the sediments. So that tells us how frequently that's happening, and that'll help us know how much the sediments contribute to this versus the watershed. So that's really, really big question. The other thing on North Pond is definitely the geology is such that septic systems probably are not insignificant compared to some of the other lakes because it's quite a sandy watershed. So that means that stuff filters through and straight into the lake without a lot of treatment. And so, so we don't know how much can be mediated through those yet, and we're working hard to collect the data that we need to do that. So going back 14 windows. So please explain again how water clarity affects phosphorus coming up into the water column and creating a bloom. So the idea is that if your lake is totally clear, and this is basically, you know, what we've transitioned East Pond to last year, where it was clear for a lot of the year. Basically, if the lake's really clear, it never stratifies because the light goes down to the bottom. And so it stays well mixed. You never have anoxia because it's mixed up all the time. So, but if your lake starts getting murky because of watershed runoff in particular, then what happens is the light doesn't penetrate all the way down, and then you get stratification. And then when you get the stratification, you get the low oxygen, then you get the low oxygen, you get the phosphorus coming out of the sediment. So if you can avoid lakes stratifying, the shallow lakes, which is what used to happen in North Pond, it used to not stratify, what happens some of the time in East Pond now, but because of the alum treatment, we keep that phosphorus trapped at the bottom rather than letting it come into the water column. And then right now, from what I can tell, McGrath mostly doesn't stratify. It stratifies occasionally, but it doesn't seem to stratify as much as North Pond did last year, for instance, and that's because the water clarity is pretty good on McGrath. So that's kind of the connection between how clear the water is and then how much phosphorus you get out of the bottom. Then is Great Pond still listed as impaired by the DEP? Yes, there is I think the process for being removed from the impaired list is not trivial, so it will continue to be listed as impaired. The trends in Great Pond have stabilized in the last 5 years since we've been taking data, but it doesn't mean that we don't still need to keep an eye on the water clarity and the anoxia in the lake, which are the reasons it was listed as impaired originally. Does the algae bloom flowing down Great Meadow Stream from North Pond pose a feral threat to Great Pond? So as discussed before, at the moment, we're monitoring the situation in terms of toxicity. There's currently no threat at the moment in terms of that, but we'll be keeping an eye on this every week through the rest of the summer, just to make sure that we all feel comfortable with that. So the next question, are the East Pond measurements at one site or two? The East Pond measurements are all done at deepest location in the lake. And so we had the buoy slightly incorrect, so that's why we had to move it last time. But generally all the measurements are done at one location. And we have this long time series of data from this one location, so that means we can compare it. So I'll try to explain again. Still don't understand why water clarity affects mixing or stratification. So if your water is very clear, so when sun hits the water, if you have, we'll do the other way around. If you have murky water, if you don't have good water clarity, when the sun hits the water, all of the sunlight gets absorbed near the surface. And that means that it doesn't penetrate to the bottom. So you end up with warm water on top and colder water on the bottom. So you get the stratification because the sun couldn't penetrate through the less clear water. And then after that happens, once you have that stratification set up, that's when you can get anoxic conditions, the low oxygen conditions, which then lead to phosphorus release from the sediments. And then in the shallow lakes, it's quite easy to mix that up again when you get wind. In the deep lakes, it's quite difficult to mix that up. So what about excessive use of fertilizer? How can we get people to stop having big lawns next to the water? So that certainly requires collective action. And I think Jen Jesperson once said it, maybe at a Great Pond meeting, that most of our soils actually in this area don't need phosphorus fertilizer. So people shouldn't be using phosphorus fertilizer if they live near the lake. And how can we get people to stop having big lawns next to the water? Well, first, I guess we all need to lead by example. And that means if you have a property, everybody needs to contribute in this way, because it's not one house, it's not one thing that leads to algal blooms. It's collectively around the lake, making sure everybody has done what they can to reduce runoff into their lake. And it's hard to get other people to do things, and instead we just need to try and work on education about why certain ways of having your property might contribute to having an algal bloom. And of course, I think we all, particularly some place like North Pond, is that we can certainly improve that through the use of lake smarts. There's all these programs that help us reduce the impact of our shoreline on the lake. So the next question is, will an alum treatment work from North Pond? The first things first is alum treatments always work, at least initially. They're inherently built to strip phosphorus from the water column and to trap it in the sediments. The question is, how long would an alum treatment work for? And an East Pond, because the East Pond Association and the people around the lake tried very hard to reduce watershed sources, that was in order to make sure that alum treatment had some longevity, right? The last thing you want to do is spend millions of dollars and have the same problem again in 5 years. And so inherently, if you do the science right, alum treatments always work for a year or two. That's basically, I haven't read of any that didn't last that long, but if you want them to last long term, You need to do that work in conjunction with watershed work because it will not last if you do not do that work. What are the next step for North Pond? So that's, so that's along those lines there. Part of this is, again, figuring out the next steps are trying to nail down where the phosphorus is coming from, like we talked about before. And so there's more measurements we need to do. It's a little more complex than East Pond was. We're working on doing those measurements. You know, it's a weird year because I don't have interns, we don't have help, we don't have as much ability to do things in the watershed besides our baseline monitoring, but we are doing things. And if there's a lake that we've done the most on extra in terms of field work, it's probably been North Pond because we've been monitoring North Pond regularly. We monitored every week last year because we knew that it was a threat that this type of bloom might happen, and we've been we monitored over the winter this year. We've been doing a lot of monitoring. We just haven't done everything that needs to be done to really quantify these loads. So we need to understand that before we start thinking about things like alum, because we need to make sure it's the right choice and that it will be effective long term. Because again, no one wants to have their alum treatment stop working after a few years because you didn't address the watershed sources enough. And Rob Jones from East Pond Association just pointed out that over 50% of the phosphorus load in East Pond was internal. That means it was all coming from the sediments. And that's why the alum treatment was the right choice, is because so much was coming from the sediments as opposed to the watershed. So another question someone asked is, why do the blooms start at one end and travel across the lake? Is that indicative of a possible source? So that's interesting because, I personally don't know that it does that. I have to take someone's word for it that the blooms travel from one end of the lake to the other. I would say it's probably more indicative of weather patterns at that time, like where the wind is blowing things. And yeah, that would probably be my guess rather than possible sources. It's so hard to track a specific source for these things. If it were easy, we would do it, and it's not going to be one source. I mean, in this day and age, like in the past, sometimes you have like a wastewater treatment discharge straight into the lake and you can pinpoint what one of the sources is. But these days, we've taken care of most of those point sources, as they're called, and now we just have a whole bunch of non-point diffuse sources, and we don't know where the phosphorus is coming from very well. And so it's a huge challenge and something we're trying to wrap our heads around so that we can figure out the best management strategy. Next question is, comment on the potential for toxin production from heating lake water in a shower. I haven't heard of toxins being produced from heating lake water in a shower, so I'm not sure that that itself is a threat. So the method of testing that we do basically destroys the cells, which means it releases any toxins that the cells may have had inside of them, which means if we didn't measure any, that means the cells are not producing toxins. So they're unlikely to produce them in the time it takes for them to get sucked into a house and used in a shower, would be from my knowledge of why and when they produce them. So right now they're not producing them at all. So I doubt they produce them in that very short period of time. Next question. Recently I saw a pontoon speeding along the Serpentine. Can more to be done to make sure people don't create a wake? That's a hard one too. I think again, we need signage for people to understand that wakes create shoreline erosion, and that shoreline erosion can contribute to phosphorus in the lakes. And so I think again, it's education and setting a good example for other people with your own actions. So, and then if needed, I guess there can be posting, but I'm not sure who is able to do that and who has the authority to do that. Okay, what has changed over the past 5 years to cause this issue to repeat itself? We have been here since 1954 with no issues like this. I'm assuming you mean on North Pond. That's a good question. Again, it's interesting. Whitney used the analogy of a Jenga game, right? And the thing about the thing about North Pond is that, you know, slowly over time, this didn't just happen in the last 5 years, and I don't have the slide handy, but if you look at what the Secchi depth has been on North Pond over the last, you know, 30 years, it actually just hasn't been as low as it should be, right? You know, in McGrath, we hit the bottom of the lake a lot of the time. In the East Pond, we've been hitting the bottom of the lake at 21 to 24 feet. In North Pond, we rarely ever hit the bottom of the lake, and it's only 20 feet deep, but it still wasn't bad water quality. It just wasn't as good as it could be for a lake that shallow. So what I'm trying to say, is that North Pond has always had a bunch of factors kind of working towards this, and ultimately it just took a combination of a bunch of things. There's, you know, things within the watershed, plus in 2018, plus the weather conditions in 2018 just set it off. And that's what I mean by lakes having stability to them. Like North Pond just didn't have that stability. It was that Jenga tower that finally someone pulled the last brick out of, and it collapsed, right? So that can take a very long time to happen. And maybe in 1954, we actually don't have the Secchi data from then to know what it looked like then, but I'll have to take your word for it, that it's in a slow decline and eventually it tipped into the condition. And certainly weird weather patterns contribute to this, right? I mean, that's, I think, something that if you've been here in this area for a long time, you know, these hot spells like we have, even if the average temperatures aren't actually hotter than they normally are, you keep getting this erratic weather, you end up with it's just more stuff happening in the lake than typically happens. It's just not as stable. So Linda Rice has posted about if you want a lake smart visit on North Pond or Little North, her phone number and her email in the chat panel. Okay, another question. So Great Pond bottom phosphorus is believed to be a major issue to be dealt with on our lake. The plan has been proactively treat with alum. Is that still being worked? So as part of the Great Pond watershed-based management plan, there is a science committee that is looking into this issue. We still don't have an answer yet, but that is on track to have a discussion about what we think the best strategies moving forward are by the end of the year. I also suggest Whitney's giving a talk at the BLA annual meeting in August, and he's going to talk more about that as well. So I do suggest, if you're specifically interested in that, to make sure you go to that talk as well. So Little Pond seems to have less algae than North Pond. Have you measured Little Pond? We have measured Little Pond. We went out, was it last week? So the water clarity is better there. So yeah, even though they're connected, it just generally seems to maintain better water quality. You know, it is much less built up than regular North Pond, so it probably has, I don't know, not regular North Pond, you know, big North Pond, I don't know what you want to call it. So it probably has less watershed runoff than North Pond, and that's one of the reasons why I'm looking into controlling watershed runoff. That is the first thing we can do straight away on North Pond while we start to look at these other options for treatment. I just have to, I like Rob's comment, lots of signs about boats going too fast, lots of signs and buoys in the Serpentine, you can't fix stupid. So how long did the process take, start to finish, to address the bloom issue on East Pond? Is this time frame something that the residents of North Pond should also expect? So, you know, I've only been here 2 years, so it definitely took, I mean, they were looking at East Pond for like a decade before they did a treatment. I don't expect we need a decade to help figure out what needs to be done on North Pond by any means. You know, we learn every time we do this. We have a lot of data already, and part of that is because back when East Pond was being studied, parallel measurements were being done in North Pond as kind of a control, right? So we have a lot of data from North Pond, and there's some more data we need to collect, but we have a good starting place. So we do not expect a time frame on the order of a decade to start coming up with a plan. You know, we're talking, we have to collect some data still, but ideally, we're starting to move forward on how we coming up with a science committee with the North Pond Association to help collect this data and to kind of figure out where we're going with it so that we can help start partitioning where we think phosphorus is coming from and come up with a management plan. So I think we can be much more optimistic than a decade for when we can start having some better information on actionable plans for North Pond. We used to have more weeds in North Pond. They have disappeared since 2010. Is it possible that their disappearance has had an impact on phosphorus? So that's an interesting question because the plants definitely take up phosphorus. So I don't know the interconnect. I don't know what kinds of plants there were there before. Yeah, so it's hard to know without knowing exactly what kind and what the coverage was. But plants do take up phosphorus, and so they can remove it in that way. But they must have disappeared. I don't know why they would have disappeared since then, though. So that's, sorry, a question that I don't have a good answer for. There's a lot of questions. If there's any more, you can see my contact info here on the screen, I believe still. Please feel free to email me or call me with questions. I'm happy to talk about what's going on in North Pond. We'll try, and like I said, we're going to do, the goal is to do toxin sampling once a week. And we'll make that information available to the lake associations, and we'll post it on our website as well, and on our water quality page, so that you can keep up to date. And certainly if we found anything distressing in those toxin measurements, we would make sure that was circulated rapidly. I've talked to the DEP regularly about this, so we're in touch with them about dealing with these issues as well. So yeah, since it's after 5, I'll please email me or call with other questions, and I'll hopefully can try and answer them. And please, oh yeah, one more, Laura also commented on this about if you're not on North Pond, you can get in touch with Seven Lakes Alliance to get connected with the Lake Smart lead for your lake as well, because North Pond, we see North Pond blooming now, but that doesn't mean that we need to be cautious on all our lakes, and Lake Smart is one way we can start protecting them and making them more resilient to future warming, more rain, all these things we expect to see in the future.